Hi, my name is Misha Kasman. Today we'll be talking about adding resilience and redundancy for your connections between on-premises and OCI. I'm a solution architect with OCI Networking. Let's jump right into the presentation. When it comes to connecting on-premises and OCI, there's three main methods to go about it. First of all, we have our public internet option. In this case, we'll have an internet gateway or NAT gateway associated with our VCN, our virtual cloud network, that'll allow for our internet-based communication. And you'll send unencrypted traffic, or maybe rely on application level encryption like TLS for your traffic that's going over the internet between your on-premises and the Oracle cloud. Next, we have our site-to-site VPN option. This is going to be using IPsec VPN to encrypt your traffic before it's going over the internet. Traffic will be routed to your VPN endpoint. It'll be encrypted, sent over the internet to the other side, the VPN peer on the other side, where it'll be decrypted and then sent to your final destination. Both of these two options will use the public internet for communication. So you're generally going to see potentially unpredictable performance there due to general internet weather events that occur. Maybe you'll see spikes in latency or drops in bandwidth at certain times a day. And to avoid that, we have our FastConnect option. FastConnect is our dedicated connectivity option that's going to avoid the internet entirely. It's generally going to be your lowest latency and highest bandwidth option available. FastConnect comes in 1 gig, 10 gig, and 100 gig port options, and is going to be giving you that predictable performance for your business critical applications that need that, as well as the high bandwidth options. Today, we'll be talking about the IPsec VPN and FastConnect solutions, how you can build redundancy with each solution individually, or combine the two together into a whole redundant solution, both in single region and multi-region use cases. So let's first talk about FastConnect. With FastConnect, we have two connectivity models available. Our first is the FastConnect with an Oracle partner option. This is leveraging existing physical connectivity that's already been established by a FastConnect partner. And next, we have our FastConnect direct option. This is going to rely on you establishing both the physical connectivity that a partner would, as well as the logical connectivity over that physical connection. You'll notice with the direct option, we have two solutions available, a co-location and a third-party provider option. Let's dive deeper into all three and talk about how those are designed. First of all, we have our FastConnect partner option. In this case, you'll see in the diagram we're in an OCI region, and associated with an OCI region, we have a FastConnect location. This is going to be a common data center like the Equinixes, the CoreSites, the Iron Mountains of the world. And in that data center, we'll be hosting our FastConnect infrastructure, including our FastConnect edge devices that terminate the physical connections. In the partner model, a partner will come in and establish physical presence within the same FastConnect location. Once they've established that presence, they'll provision redundant fiber cross-connects between their edge devices and the FastConnect edge devices. So when a customer comes in and decides to onboard using a partner, you'll establish physical connectivity to the partner network, and from there, build your logical connectivity, your virtual circuits, over that connection through the partner network, then over those cross connects, and then into your OCI environment, accessing your private resources within OCI. Next, in the direct option, specifically co-location here, we're going to remove the partner from the equation entirely. Instead of the partner having a physical presence within that FastConnect data center location, you, the customer, will. You'll work with the data center operator to rent your own physical space within that data center, and then you'll install your own physical infrastructure there, your routers, your switches, etc., whatever you may need. Once you've established that physical presence within the FastConnect location, like a partner, you'll build out your redundant fiber cross-connects between your edge devices and the FastConnect edge. Once that physical connectivity has been established, you'll build your logical virtual circuits over those physical connections to, again, gain access into your OCI resources. With the third-party direct model, the major difference here is that your customer edge has moved from within the FastConnect location all the way back to your remote physical data center or on-premises location. In this case, you'll leverage a network carrier of your choice to establish physical connectivity all the way to the FastConnect edge. This can be leased lines, dark fiber, Metro E, whatever option is going to give you that physical connectivity all the way to the FastConnect edge. Most of the times, this model here is used by customers that are maybe in a physically isolated location, or a location that's not serviced by a pre-established FastConnect partner. Likewise, once this connectivity has been established, you can build your logical virtual circuits over that physical infrastructure to gain access into OCI. Now, we've talked about physical connectivity. Let's talk about these virtual circuits I brought up a couple times. Virtual circuits are the other side of the coin when it comes to FastConnect. The FastConnect solution is a combination of physical and logical connectivity. Virtual circuits are the logical. They're what ultimately give us access into OCI. And virtual circuits come in two different flavors, private peering and public peering. Private peering can be thought of as infrastructure extension. This is accessing private IPv4 or IPv6 address space somewhere else. In this case, that somewhere else being the OCI cloud. On the other hand, our public peering option is the internet alternative option. Let's say you have a public PaaS or SaaS endpoint you're communicating with in OCI. This can be object storage, maybe a SaaS like Fusion Apps or Oracle Analytics Cloud. All those are generally accessed via URL that resolves to a public IP that's reachable over the internet. Those same IPs can also be reached over a public peering virtual circuit. So if your use case requires you to access those services, but have the benefits of FastConnect, the dedicated connectivity, predictable performance, and high bandwidth options, you may decide to go with the public peering option. You'll route that public traffic over that virtual circuit instead of the internet, gaining you access to those same resources. Basically any public IP within OCI Cloud. Most of the conversation in this presentation is going to be focused around the private peering option. However, the same concepts for physical and logical redundancy can be applied to public peering as well, with the addition that with public peering, because the internet path is always available, that can be used as a failover. Some customers may decide to use multiple public peering virtual circuits and fail over between them in the case of outages, or they may decide to have a single public peering virtual circuit, and in the case of a failure, rely on the internet as the backup path. Both completely valid options. So now that we've talked about what combines to form a FastConnect solution, the physical and the logical, let's talk about the building blocks that we have available to us to build our redundant FastConnect solution. When talking about FastConnect, it's important to understand these building blocks before we talk about how we can combine them together to form our solution. So when it comes to using partners, we will always have multiple partners available in any OCI region. You will always be able to pick and choose between multiple ones, depending on who you would like to use or prefer. Each partner, when onboarded onto the FastConnect solution, are mandated to build redundancy. They will always have redundant physical connections to different FastConnect edge devices, meaning there is never a single point of failure between the partner network and the Oracle edge. This gives customers that choose to rely on a single FastConnect partner the option to build redundant options, avoiding single points of failure. Likewise, we talked about a FastConnect location earlier. Some of our regions will have more than one FastConnect location. They'll have two. These are going to be regions like Ashburn, Phoenix, Frankfurt, Amsterdam, our larger regions. But all of our other regions will always have at least one FastConnect location. Each of these FastConnect locations will also have a minimum of 2 FastConnect routers that you can terminate your physical connections into. This will give you that option to build out your device redundancy as much as you require. So now that we've set the stage, let's talk about how we may decide to build our physical connectivity. Let's say I'm in an OCI region here that has 2 FastConnect locations available. That means I have 4 FastConnect routers available to terminate my connection on. And let's say I've established my first cross-connect on a FastConnect edge device 1 in location 1. Now I have 2 options to establish my second cross-connect. I can choose to establish it in the same FastConnect location, just a different edge device, or I may decide to go in a second FastConnect location. Now these 2 FastConnect locations are going to be in the same general metro area, but they're going to be completely isolated and different data centers from each other. My choice to go into the second FastConnect location may depend if I want that location diversity, right? I want to avoid a single point of failure, meaning the whole data center. If there's a catastrophic outage that occurs and the whole data center goes down, me being in the second FastConnect location ensures I have a redundant path available to me. However, that comes with certain trade-offs. Investing in building infrastructure in the second FastConnect location is generally going to involve additional cost associated with it. So if if redundancy within locations is not critical to me, or maybe I'm in an OCI region with a single FastConnect location, I may decide to establish my second cross-connect within the same FastConnect location. Either way, I ensure that I have that full diversity on the OCI side. If a single router goes down, I still maintain connectivity over my backup path. Now that we've talked about physical, let's talk about building those virtual circuits, our logical connectivity over the physical infrastructure. These cross connects that we've established can be thought of as layer 2 connections, and virtual circuits are layer 3 connections. Because of that, we'll require to have at least 2 virtual circuits, one per physical cross connect. In this case, I've built virtual circuit 1 on cross connect 1. Ultimately, this goes over FastConnect edge device 1. And I've built my second virtual circuit over that redundant cross connect that goes over the second FastConnect edge device. Both virtual circuits logically then attach to the DRG, the dynamic routing gateway, to give you access into your OCI infrastructure. You'll notice here on the left, I do technically have a single point of failure with the customer premises equipment, the CPE. Depending on what level of redundancy I need, if I want that hardware redundancy on my on-premises side, I may decide to split that up into 2 devices, ensuring if I need to take my CPE down for maintenance or there's an outage, I still have a fully redundant path available to me. This would have the hardware redundancy on both my on-premises and the FastConnect location side, as well as link redundancy between the cross connects that go between the devices. Now that we've talked about a direct model, let's talk about our partner options. And our partner options will come in 2 flavors. We'll have partners that offer layer 2 connections and partners that will offer layer 3 connections. Layer 2 connections in this case are going to be very similar to our direct option, with the main difference that it's the partner that builds the physical connectivity between their partner edge and the FastConnect edge devices. And you would be responsible for provisioning the logical connectivity, the virtual circuits over that physical infrastructure. In this case, as I talked about earlier, each partner is going to be mandated to build that redundancy. So we'll have the option of multiple cross connects when we provision those virtual circuits within the partner portal. And each virtual circuit should terminate on a different cross connect so that it goes to a different FastConnect edge device, ensuring that level of redundancy. We're also going to use our BGP attributes like local preference and AS path prepending to influence our ingress and egress route preferences. So this is what this looks like in a diagram form. You'll see we have our partner network in the middle now instead of our physical cross connects directly between our edge device and the FastConnect edge. And when I provision my virtual circuits, they'll be going over redundant partner infrastructure through the partner network, through the partner edge to the FastConnect edge, and then into the OCI environment. We'll provision our 2 virtual circuits exactly like we did with our direct option over 2 different cross connects. And again, we'll be able to choose which cross connects we provision our virtual circuits on to ensure we have that redundancy. What's critical here is to do some additional verification and ensure that when you're provisioning your virtual circuit, you're not accidentally provisioning your second one on the same cross connect so that you don't have an illusion of redundancy when both end up going over the same physical infrastructure. When you provision them like this on different cross connects, you can ensure to have that hardware redundancy through the partner network. Next, let's talk about layer 3 connections. Layer 3 connections are a little bit different from layer 2 and direct. The primary thing to understand with layer 3 connections is that a single virtual circuit is automatically designed to be redundant and diverse. You don't by default need a second layer 3 connection to ensure that you have redundancy. This is done by the partner not only managing the physical cross connects that are established like in the layer 2 model, but in addition to that, they're also going to be managing redundant BGP sessions between their partner edge and the FastConnect edge devices, ensuring there is always the ability to fail over in a single virtual circuit model. What's critical in this option is that you avoid any single points of failure along the whole path, meaning in addition to establishing a layer 3 virtual circuit, you'll need to ensure that your physical connectivity between the on-premises and your partner network are redundant to avoid that single point of failure. So this is what this looks like in the diagram. Again, we have a partner network, and we have a single logical virtual circuit through that partner network. We're going to have a single BGP session that's going to be directly between your CPE and the partner edge. And there will be separate BGP sessions between the provider edge devices and the FastConnect edge devices. In this case, we have two physical connections, two different cross connects going between two different provider edge and FastConnect edge devices on the right, and each one will be running a BGP session. Traffic will flow over one of those cross connects, and in the case of, let's say, the cross connect going down or one of the edge devices, there will be automatically a failover to the redundant BGP session, and traffic will fail over and flow over that redundant connection without you needing to do anything additional or establishing additional virtual circuit. Now, there may be scenarios where it's critical to establish a redundant layer 3 connection if you already have one. We talked about earlier having location diversity in the case of multiple FastConnect locations. It may be something you want to achieve here as well. You want to avoid that scenario where a single data center outage is going to impact all your connectivity into OCI, in which case you may decide to provision a second layer 3 connection, maybe with the same partner or a different one, to a second FastConnect location to avoid that data center outage. In addition, you may want to have partner redundancy as well to avoid any sort of outages within the partner network impacting your full connectivity to OCI, in which case you can decide to establish a second virtual circuit, either the same partner, or I'm sorry, a different partner, which can be layer 2 or a layer 3 partner, depending on your choice. You'll still have that redundancy between virtual circuits and between partners, avoiding that single partner point of failure. Now that we've talked about FastConnect, let's look at VPN and how we can use VPN to build redundancy. Just like with FastConnect, with VPN, we want to ensure that our customers will have a level of high availability, meaning multiple redundant devices on the Oracle side to ensure there is no single point of failure. With IPsec VPNs, we have what's called an IPsec connection, which can be thought of as like a logical bundle of multiple VPN tunnels that are inherently going to be highly available between each other. Each tunnel within an IPsec connection is going to terminate on a different VPN gateway on the OCI side, so that if you have both tunnels up and one of the VPN gateways goes down for whatever reason, like maintenance, you can still fail over to the second tunnel and maintain connectivity into OCI. You can also build additional IPsec connections depending on how many tunnels you need. And each tunnel will have its own BGP session that you can use to influence your traffic path accordingly. So in this case here, we have a single IPsec connection. You'll see each tunnel is terminating a different VPN gateway. And from there, each VPN gateway is attaching to your DRG to then give you access into your OCI environment. And there's a couple of different options here when we can look at redundancy. We can leave it like this and rely on a single internet provider and our single CPE on the left, and our redundancy will only be on the OCI side and between the two tunnels. But what if you want to build additional redundancy? Let's say you want to have a second CPE. You can build a second IPsec connection to the second CPE. And that way, if there is a failure on that device, or you need to upgrade it, maybe take it offline for any sort of reason, you can still have an up path available over your redundant hardware. This can also be expanded to redundant internet service providers. Let's say you have two ISPs available to you in your on-premises location, in which case you may decide to build two IPsec connections, each going to a different public IP belonging to a different ISP link that you may have in your on-premises. This will give you an additional level of redundancy in the case of your internet service provider going down. You can also decide to use multiple tunnels as a way to get additional bandwidth. Oracle does support ECMP, or equal cost multipath, across multiple VPN tunnels, so that if a single VPN tunnel doesn't meet your bandwidth needs, you can logically group multiple tunnels together, currently up to 8, and do flow-based load balancing across those tunnels to ensure you have that additional bandwidth. Depending on if you want to use ECMP or an active-passive scenario, both can be built in patterns such as this diagram to ensure you have a fully HA solution when connecting to OCI. Now, we've talked about FastConnect and VPN individually. What if we want to combine the two solutions together? Let's say you have a FastConnect, but you don't want to invest in a second one. You'd like to just use VPN as your backup option in the case of a failure. You can completely do that. In this case, you'll provision an IPsec connection or potentially multiple if you want to use ECMP for additional bandwidth. And you'll want to have at least one, or optionally multiple tunnels up, to ensure that if FastConnect does go down, you have an active tunnel already available to you to fail over your traffic. We'll always want to ensure FastConnect is our primary path here, because that's our dedicated connectivity, right? It's going to give us that lowest latency, the highest bandwidth. So we want that to be our preferred path. We highly recommend to use BGP for the route exchange here as well. With FastConnect, you'll have to use BGP, but with the VPN, you have the option of both BGP or static routing. Using BGP for all of your connections is going to give you a much easier time in managing your redundancy. You're going to manage a single routing protocol instead of worrying about managing both static routing and BGP. Failover is going to be easier to design and predict, especially when you have multiple VPN tunnels in this kind of scenario. And the last point here on the slide is very critical to know, in that when sending traffic back to on-premises from OCI, we will try to always prefer the FastConnect path. When we send traffic back, this is always going to rely on AS path length within the BGP attribute options. The shortest AS path length is, of course, going to be preferred over a longer AS path length. And this is what we use to prefer FastConnect over VPN. Let's say we have a scenario where you advertise the same on-premises route to OCI across both your VPN connections and your FastConnect. And let's say you're using the same AS path length of 2 for both the VPN and the FastConnect. When we learn those routes and import them into our own BGP session, we'll do no additional prepending on FastConnect. We'll leave it as that same AS path length of 2. And for VPN, if we're using BGP, we'll add an additional single prepend. If static routing is used for VPN, it'll actually be 2 prepends, so even less preferred. In which case, when we send routes back to your on-premises destination, we'll use that AS path length as the tiebreaker. FastConnect will see an AS path length of 2, VPN will be 3, and we'll prefer the FastConnect path back. You can rely on that behavior and that tiebreaker to ensure FastConnect is always preferred by advertising the same AS path length on both connections, or you may decide to be deterministic at all times and avoid any sort of tiebreakers, in which case you can manually yourself do additional prepending on your VPN routes and ensure we'll always send traffic over the FastConnect regardless of this default behavior. So we've talked about single region. What if you have multiple regions that you're consuming within OCI? We'll first talk about a remote on-ramp scenario. In this case, you're consuming 2 OCI regions, Region A and Region B, but you maybe only are able to form a connection into a single region. In this case, our Region A on the top left. This way, we can still get connectivity to Region B via the OCI private backbone. Our backbones between regions are all built to be resilient and highly redundant. So you can take advantage of that redundant backbone by building what we call a remote peering connection between our 2 DRGs in each region. You only need a single remote peering connection, or RPC, to take advantage of that fully resilient backbone. And an RPC is going to give you that private path between the regions over that backbone, using your own private IPv4 or IPv6 address ranges. Traffic will be routed from on-premises to the DRG in Region A, and if our destination is Region A, it'll go directly into your VCN of choice. If our destination is Region B, it'll be routed to that remote peering connection over the backbone to Region B, and then ultimately to the final resource through the DRG. However, if you are able to establish a connection into Region B, you can have a redundant scenario such as this. In this case, we have a single VPN or FastConnect in both Region A and Region B, and we can make those 2 cross-region connections be redundant with each other. In this case, for my on-premises when I'm sending traffic to either region OCI, I have a couple options available to me. I can either do an active-passive or an active-active scenario. Let's say I want to do active-passive, in which case I always want to have one single FastConnect or VPN be my active path. This is similar to the remote on-ramp scenario, but with the addition of cross-region failover. Traffic will be routed over a single virtual circuit or VPN, go into Region A or B, either locally or over that remote peering connection. Or I maybe want to do an active-active and say, if I want to access Region A resources, go over my FastConnect or VPN tunnel Region A, if I want to access region B resources, go over my FastConnect or VPN tunnel in region B. In the case of a failover, only then would we resume a remote on-ramp scenario where traffic is routed over the backbone to get to a remote region. Now, what's important to know here is how we prefer our routes from sending traffic back to your on-premises. Couple of concepts. First of all, we don't do additional prepending between OCI regions over that remote peering connection. If you advertise an AS path length of 2 to region A, and I'm looking at my route table on the DRG in region B, the AS path length will still be 2 over that remote peering connection. However, we'll also prefer hot potato routing the traffic, meaning if I see the same route available to me over an on-premises connection like a FastConnect or VPN tunnel and my remote peering connection, I'll always prefer to route it out that local FastConnect or VPN tunnel and only use my remote peering connection as the backup path. So that only in the case of failure in the local region having my FastConnect or VPN go down, only in that scenario will I prefer the remote peering connection path because it'll be the only backup path available to me. This way you can build your DR scenario or multi-region scenario in a highly scalable way, ensuring redundancy between multiple connections in each region. So we've talked about FastConnect, we've talked about VPN, and how to leverage those either by themselves or together to build our redundancy and resiliency in a single region or multi-region scenario. I want to thank you all for your time and joining me today. Have a good rest of your day.